Okay, so what I plan to do on this video is show you how to perform a hypothesis test um, that tests the population proportion, P. So this is we're gonna use our template that I've created for you, and I'll then run through how to show you, with the TI graphing calculator, how you grab the bits and pieces out of it as well. All right, so let's read through this question. So it says, some people are concerned that new, tougher standards and high-stakes tests may drive up the high school dropout rate. The National Center for Educational Statistics reported that the high school dropout rate for the year 2000 was 10.9%. All right, so in other words, the population proportion of students who are dropping out back in the year 2000 is 10.9%. So remember, when we write percentages, we're gonna drop the percent sign, which means that this decimal point will have to move 2 decimal places to the left. So we'll write this as 0.109. Okay, so one school district on Long Island, whose dropout rate has always been very close to the national average, reports that 210 of their 1,782 students dropped out last year. All right, so in other words, they just handed us, N, how many students there were total, which was 1,782, and then X. Remember, X usually represents the number of students that say yes, or the number of people in a population that say yes to the question, which in this case was, the question is, did you drop out? And 210 dropped out. All right, so the question says, is there experience evidence that the dropout rate is increasing? Test at a 5% level of significance. All right, so we already established that the null hypothesis, H sub 0, the population proportion, P, is equal to 0.109, which is 10.9%. So let's pop that in there. So this is 0.109. That always has to be written as a decimal. You can't work with a percent sign inside of formulas. All right, so then the alternative to that, well, that gives us that right there. This second to last sentence here. Is there experience, that evidence that the dropout rate is increasing? In other words, is it the national average? Is it 0.109, 10.9%, or is it higher than that? All right, so in other words, P greater than 0.109. So there's my alternative. All right, so let's jot down what they give us in the question. So the number of samples here was 1,782. X, the number of people that say yes to the question. Well, in this case, it's how many students dropped out. That was 210 in their sample. And then obviously that's going to give us a P hat. All right, so let's see what that is. Let me just underline this. All right, so P hat, which is X divided by N. In other words, this number here, 210 divided by 1782, what is that percent? Let me grab that. All right, so this is going to be 210 divided by 1,782. All right, so let's pop that in the calculator. I don't like to see this as a decimal. I would prefer to see it actually as a, I don't like to see it as a fraction. I prefer to see it as a decimal. So I'm going to pop it in the calculator really quick. This calculator is always crashing on me. It's the electronic version. It doesn't work very well for me. So 1782. So what I'm doing is I'm just dividing these two numbers. I want to see this as a decimal. Because I'd rather know what that percentage is in my head. All right, so right now this is 0.1178 approximately. So if you move that decimal in your head, just move it to the right, that's 11.78%. The national average is just under 11%. As you can see, this is a little bit higher. So this school district is kind of concerned. They're like, wait a second, the average is about 11%, and now we're having something, upwards of 12%. So, these high stakes tests, is it kind of deterring students, and, students are kind of giving up and they don't want to take these tests. All right, so let's round this. So typically, like a probability, we would keep 4 decimal places. So I'm going to keep 4 here, 0.1178. That seems like a pretty good number there. So 0.1178. Let me close this, it'll pop it in over here. All right, so there it is. All right, so there you have it. All right, so now the distribution. Unlike testing means, where you have to worry about normal distribution and t-distribution, testing the population proportion, it's always assumed to be a normal distribution. So we're going to use z-scores. All right, so let's go ahead and fill in this table. Let me just clean this up a little bit. All right, so I need my alpha, and they gave that to us, right? That's 5%, so 0.05. All right, now I need my critical z-score. All right, so let's go to the table here. So remember, your critical z-scores, they always come from this table here, which is your mini z-score table. The t-scores, remember, over here in table 3, but this is not a t-score table. As a matter of fact, this questions involving the population proportion, if they work with the assumptions, are always using normal distribution. For us, it's n times p and n times q being greater than 10%, which we could check that if you'd like. This question works out there. All right, so we're going to grab this. And the only problem is, what do I have, a one-tailed distribution or a two-tailed distribution? Well, I kind of gave it away, obviously, because I already shaded the region, but I did that on purpose just to save myself some time here, being that I'm working in Microsoft Word. But the alternative hypothesis has a greater than symbol in it, which means you shade on the right. Remember, if this alternative hypothesis had a less than symbol in it, then you would shade on the left. And then you would shade on the right and left. That would be a two-tailed test if the alternative hypothesis had a not equals to sign in it. Now, some people always ask me, how would I know whether it has a not equals to? Well, let's say this question right here, this piece. What if it said, is there experience evidence that the dropout rate is different than 10.9%? They said something to that effect. Different meaning what? More or less? What if they didn't specify? Like this question specified, increasing, higher than. So it kind of gives it away that it's a right-tailed test. But, not every test is a right-tailed test. All right, so let's go. So let's grab our z-score. So this is 5% alpha, one tail. So if I go over here, here's the one tail column, 5% alpha. So this is 95% confidence, 5% alpha, plus or minus 1.645. All right, so we got to grab the one that's appropriate for our test. Since we're on the right-hand side, this is positive 1.645. In my math lab, when they want that to 2 decimals, I believe you use 1.64. All right, so I'm going to move this arrow out of our way. We pop that z-score in there, 1.645. So remember, that is the boundary between this region here, which is 95% of the area, and then this little tiny shaded region here, which is 0.05, which is 5% of the area. All right, so while we're here, let's go ahead and state our decision rule. So remember how the decision rule works. Let's see how this works. I'm a little higher than I wanted to be here. Just try to fill that in. Above this region, remember you write fail to reject, h sub 0. Above the critical region, reject h sub 0. Remember, this is called the decision rule. So once we crunch this testing statistic, if the testing statistic lands to the right of 1.645, it'll land in the critical region, and therefore the decision rule says reject the null. If this testing statistic, once we crunch it, lands to the left of 1.645, it'll land in the non-critical region, somewhere along this part of the number line, in which case the decision rule says fail to reject. In other words, don't reject the null hypothesis. All right, so think about it. We've collected our hypotheses. We've written down the appropriate information, made a decision on our distribution, which is normal distribution. We've drawn our picture, shaded our region. We got what kind of a test it is. It's a one-tailed test on the right-hand side. We stated our decision rule. The only thing left to do is to go ahead and crunch the testing statistic and see where it lands, and then we could pass our judgment on the result of the test. All right, so let's go ahead and pop this information in here. All right, so here's the testing statistic formula. All right, so p hat, we got it. There's p hat. That's the sample percentage. In other words, remember, that's the thing that's being used to compare to the p. All right, it's 0.1178. Subtract off p, which is 0.109. All right. Divided by radical p times q over n. All right, so p we got, that's 0.109. Now, what about Q? Well, Q wasn't given anywhere in the question, if you could see. It wasn't given anywhere, right? All right, so we're going to need our calculator again. So remember, P and Q, they have to add up to 100% or 1. So if you take 1 and subtract off 0.109, in other words, if the national average is 10.9%, those are the kids that drop out, then what about the ones that don't drop out, the ones that actually graduate? All right, that's 0.891. It's about almost 90%, obviously. So what's going on here? These are the people that say no to the question. Like, no, I didn't drop out. So, all right, so this is 0.891 divided by the sample size, which was 1,782. All right, obviously we got to crunch this in the calculator. So it's going to be a little annoying to type, but let's go ahead and do that. Let me clear this mess out. All right, so you open a set of parentheses. So 0.1178. Subtract 0.109. Close the parentheses. Divided by a big radical. So second radical. Now, you see how you open and then you close. Open, close. In a calculator, you don't want to play that game. Notice how my calculator, I have the old-fashioned one, it opens that parenthesis right there. Don't open anymore. Just type this expression. In other words, the calculator, it's got PEMDAS. Please excuse my dear Aunt Sally. It's got it pre-programmed. So let it take care of all the parentheses and everything. So 0.109 multiplied by 0.891 divided by 1,782. And then just close it once. So open it once, close it once. There's our z-score. It's about 1.19, right? This is about 1.19. All right, so let me close this and it'll pop it into our template. So there it is. All right, so let me move this a little bit to the left. Try and create some room here. And grab this arrow. Now think about it. That's the number 0. That's about 1.6. 1.19, it's like 1.2, right? It's got to be like somewhere over here. So I'll pop this like right over there somewhere and try to stretch this a little bit. It's right in that ballpark. I mean, this isn't rocket science here. We don't need to be perfect. We just need to know approximately where it lands. The only thing I really care about is that it lands on the left of the testing of the critical value. The testing statistic does not land in the critical region. So remember, the decision rule says fail to reject the null hypothesis. All right, so result of test. So all right, fail to reject H0. All right, so why did I fail to reject? I failed to reject because the testing statistic did not land in the critical region. If the testing statistic came out to be something, say, like, 1.8, then this thing would land out here somewhere, and then we would have rejected the null hypothesis. All right, so the second you get this result, you go right up to the null, right next to it, and write what you're doing. I am failing to reject. So I'm going to highlight that. I am not rejecting this claim. So if you're not rejecting this claim, then the one underneath it, obviously you got to say the opposite. We are rejecting the alternative hypothesis. So let me highlight that as well. So if you're wondering, why are you writing this here? Well, I'm writing this here. It's going to help me organize my thoughts because I want to come up with some kind of conclusion right now. Because the question asks me, is there evidence that the dropout rate is increasing? Well, here's my statement that says it's increasing. The alternative, the population proportion is greater than 0.109. Reject. We're rejecting this claim. All right, so is it increasing for them? No, obviously we're not. Since we're failing to reject that it's still about 10.9%, notice we're not saying accept that, by the way. That's a crucial thing. We're not saying accept here. But we're rejecting this statement that it's, in fact, increasing. All right, so we come down here based on the given information. The dropout rate is not increasing significantly. So a lot of people say, well, why don't we just say accept right here? Why do we say this fancy phrase, fail to reject? Well, the bottom line is we're not asking everyone in the population, did you graduate or not? So, we don't really know what this number is in theory, right? So we don't say accept to this, being that we don't ask everybody. So we're just saying, listen, we don't have enough evidence to reject it. So since I don't have enough evidence to reject it, we're going to say fail to reject. All right, so hopefully this helps you out a little bit. If you have any questions, shoot me an email. Thanks for watching.